Good afternoon to all who have just joined us at Tech Innovation 2021. In the next program, we will be exploring how reducing waste and adopting a circular economy approach can greatly improve the environment and bring economic benefits. Before we start in a few minutes, I would like to remind everyone that all attendees will be muted throughout the session. Should you have any questions during the presentation, please type them in the Q&A feature on your screen. We will answer as many questions as we can during the panel discussion towards the end of this session. First, we have Morgan Yeo from Roger&Sons, who will share how local trees are turned into sustainable products and the current state of Singapore's felled trees from a maker's perspective. Over to you, Morgan.
Hi everyone, my name is Morgan, and I just want to thank everyone for just taking time to just be here today with us to be part of this sharing session. Like the introduction, my name is Morgan, and I'm a director at Roger&Sons, and today my topic will be fallen trees to sustainable furniture. So a little bit more about what we do for a start. So at Roger&Sons, we are a team of ethical makers and mavericks who craft fine furniture and thoughtful products and objects. Our work is driven by inquiry and spans disciplines such as furniture, industrial, and product design. And our main focus is woodworking. So basically what we do is we are a blend of old and new. We have older guys that have been around for a long time. We have been in the industry, and my dad started the business close to 33 years ago. And ever since me and my brothers took over, we have since gotten a lot of new blood into the company. And what we try to do is we try to get the older carpenters, the more established carpenters, to work alongside these younger guys to share some of the techniques that we have, as well as just try to push down the boundaries that we. So like I say, some of the things we do are industrial design, furniture design, design consultancy, woodworking, and furniture restoration. So this is just an image of the team that we have right now. So our company goals are actually to, number one, to try to preserve the dying trade and educate future generations about Singapore trees as well as woodworking. We want to be a lot more environmentally sustainable in our company, and we would like to start by changing the process from the start to the end. And ultimately, what we want to be is to be the voice and play a part in steering the industry, the woodworking industry, to be a more sustainable and eco-friendly one. So I just go straight to the topic that I would like to talk to you about. So the one that I'd like to talk to you about is the local tree project. So the local tree project was actually started about 3 years ago. Mandai Development as well as Tan Tock Seng came to us about 3 years ago to ask us to explore whether or not we could take some of the trees that they have cut down, that they have fallen for the new developments, and turn them into furniture to be placed back at the parks. We told them that it's our first time trying something like this, and we told them that if they're willing to undergo this journey with us, we will be able to explore it and learn together with them. So we started going to the sawmills, we started trying to get to know more about the industry. And after a year and a half, we placed the items back at Mandai, as well as Tan Tock Seng. I'll show you guys more photos later. So as we started talking to all these sawmills and we started talking to people, we realized that in Singapore, there's quite a lot of trees that has been cut down every day. When I speak to the sawmills, in Singapore, there's about 3 to 4 sawmills left. The sawmills tell me that there's about 50 to 100 trees that has been cut down in Singapore on average. I don't have any way to fact check that, but I think there has to be some truth for these guys to say something like that. So the whole process is quite straightforward. Whenever there's a new development, whether it's road expansion or anything else, Singapore will cut the trees down, and a certain percentage would go into mulch. So about 10% will go into mulch, where they be used as fertilizers back into the area. The remaining amount, the landscape companies are supposed to dispose of them. So instead of disposing of them, because you have to pay money to dispose, these sawmill companies, these landscape companies will go to the sawmill and sell the trees by the truckloads, like a couple $100, and they just sell it to the sawmills. The sawmills will then do three things. Firstly, they'll change it to pellet. Secondly, they will turn it into big bullets that will be used in the shipyards. And the third one is that they process and mix all the different woods, and they will export it over to China and neighboring countries and call it mixed hardwood. These timber are not processed properly and are placed, for example, underneath your sofas and stuff like that. So this is actually an image of one of the sawmills that we have been through in Singapore. The idea is, for this place, you can see in the image, this is almost the size of 4 Olympic-sized swimming pool. The logs are stacked up about 3 meters high. And I always tell people that in my entire lifetime, I will never be able to finish using all of these trees. And this is just one location. There are many other locations in the sawmill that have trees stacked up as well. There was also an article that came out in the Straits Times a couple years ago where they said that there'll be 15,000 trees that will be cut down in the next 15 years. So what we wanted to do was to see whether or not we can explore taking some of these trees and turn them into furniture. So the issue with Singapore is that we are not primarily we don't process tree, and we are not a plantation. So all the trees in Singapore, whether it's grown in Bedok or whether it's grown in Clementi, they all grow differently. The trees will try to follow where the sun is. So certain trees might go straight and then it might turn a little bit, or certain trees would just go, some are shorter, some are longer. So because we don't have consistency of the trees, number one. Number two, because of the knowledge of the sawmills, the guys at the sawmills are not very high, because most of them are slightly older in age. So they're really not used to trying to process the trees properly. So that's the reason why they have not processed the trees and turned them into furniture. So what we have done over the last couple of years is to go to these sawmills and try to help them clean up their process, help getting them to kiln dry the wood properly, getting them to work with the different wood properly. And it has been quite an interesting journey. Some of the trees that we work with quite commonly, it's the Angsana tree, the Kaya tree, as well as the rain tree. The Angsana and the rain tree are natives to Singapore. The Kaya was actually brought over from Africa in the 1970s when Singapore wanted to be a garden city. Just a fun fact for you guys is that whenever Singapore cuts a non-native tree, they are only planting back native tree. So in the next 20, 30 years, we will only have native trees back in Singapore. So what we have done is processing trees and working in local wood is not a new concept. It has been done all around the world, but it's a little bit more interesting in Singapore because we are not known to have, we're not a forest, right? So we're not known to be able to process tree and create our own wood. So what we have done is, first step is to get the basics right. We have helped with the sawmills and get the processes right. The second step we have done is we actually are doing research and development right now. So we contacted IPI last year, and they have introduced us to ICA. And together with Design Singapore, we have gotten the Good Design Research Grant, where we are actually taking some of the local trees in Singapore, and we are working together with ICA to learn how we can densify these local trees. We are also having certain plans to work with the byproducts of the tree. So we're working with to see how we can work with the bark, the sawdust, as well as the branches to see whether or not we can come up with more interesting products. So these are actually some of the things that we've done. So this is quite interesting because for Monday development, they pass us 2 big, humongous logs. The diameter of the logs were about 2 meters. So it's about my height. It's higher than me, sorry, it's taller than me. And they gave us 2 logs. And out of the 2 logs, we created 50 different furnitures that were placed around the different parks. So these are some benches. This is a bike rack that's placed right now outside Mandai. Certain tables and benches. We even did some fixtures for some of the animals in the enclosures. We also have this project that we did with Southern Gate. So this was a project that we done with URA. The interesting part about this project is that the furniture that we made from this project were actually felled at Ophir Road, just down the road. So we took those trees that was cut down. They were cut down because of the road expansion, and we turned them into furniture to be placed in the parking lots at Southern Gate. You could see we did like spinning tops. We did this is a cajon, so you can sit down on the wood and then you could play on it. And you could see my brother just sitting and playing, and we made this to look like a gasing to loosely follow the Malay spinning top. Yeah, these are some other images as well. So one of the things that we're doing with the local tree project is actually working and trying to bring the costs down. You know, one of the biggest issue about being sustainable and working in Singapore and trying to be sustainable in Singapore is that the cost is really high. Most of the time, the reason why there's no adoption to working in local wood is because uh, there's always an easy option to import wood. You know, it's easier to import wood than process wood in Singapore, and I find that really hard to understand. The cost of processing wood is really expensive. So, for example, when we kiln dry a wood, we will cut out all the barks and then we'll kiln dry the wood. The rest of the bark, for example, would have to be thrown away and you have to pay money. However, in overseas, you're allowed to burn the wood down and generate electricity and heat that can be pushed back into the kiln. But in Singapore, because we're not allowed to do that, that kind of drives the price up. So we are kind of in a chicken and egg problem. So when there's more people adopting and trying to adopt and use local wood, the cost will go down. So I was talking to a lot of people and talking to different people, we realized that one way to be able to get people to be interested in what we do is to be able to drive the price down and to have more entry-level products. So we recently started Roots and Stumps, which is solely focusing on sustainable products. So we're working with creating like chopping boards, trays, more lower entry items. And the densification of local wood that we're doing together with ICA would also be, once we have the results, we'll design stuff and we'll also sell it there. And the idea for this is to be able to make this a little bit more mass, to be able to share our knowledge and whatever we have learned to not only to the general public, but to other carpenters as well, so that they'll be able to adopt and learn on how to use the local wood. I think the key for us is that because we are cutting down so many trees every day, it actually makes a lot more sense for us to see how we can be a little bit more self-sufficient with our natural resources. So instead of disposing of the trees, it's key that not only me, but the industry itself continue to explore ways on how we can process this wood and bring better use to it. Okay, with that, I would come to the end of my presentation. And if there's anything else, you just let me know. And if you have any questions, please feel free to put it down. I'd be happy to answer them later. Thank you.
Thank you, Morgan. Now, following his insightful presentation, Dr. Sun Xiaolong from Zerowaste Asia will be sharing how Singapore can realize its near zero landfill goal, as well as potential solid waste disposal and recycling solutions. Dr. Sun?
Thank you for the introduction. I'm glad to be here to share some thoughts and ideas. Today, my topic is about converting waste to resources and achieving a near zero landfill. I want to start by introducing the Singapore waste management model. We all know that we generate a lot of municipal and industrial solid waste every day. 16,000 tons of this kind of waste is generated in 2020. And out of this, 52% is recycled. This is not the best figure we have, but because of the COVID-19, this number has dropped last year. And the rest, 48%, some are incinerable, some are not incinerable. So whatever can be incinerated, they will go to the incineration plant. We have 4 incineration plants in Singapore in operation. The non-incinerable waste will go directly to our landfill at Samcorp, and it will be fully filled in 2035. And on the other hand, if you look at the incineration, it's not the final solution. After incineration, 20% of the waste will become incineration ash, which include bottom ash and fly ash. This will consist of 1,700 tons every day going to the landfill. So it's a big volume. That's why when we talk about near zero landfill, we cannot stop involving all these three sections. The first is we need to push up the recycling rate, which is now 52%. And second, we need to address the non-incinerable waste, which is not combustible and sent directly to the landfill. And the last part is a major part, will be the incineration bottom ash and fly ash. So next, let's look at the waste statistics of Singapore. We have the last 5 years data here. As you can see, we have done some good job with waste like construction and demolition waste, ferrous metal, paper, wood, but we didn't do well in some of these guys here, which are plastic waste, food waste, ash and sludge, textile, glass, and other waste. So what are the reasons that cause this low recycling rate? The reasons are multiple, actually. First of all, the collection issue. For example, for food waste, it's going to cost a lot to collect the food waste from food court, from organizations, from canteens. And more importantly, the food waste collected will have a large amount of foreign matters like chopsticks, plastic forks, plastic bags, straws. So this will seriously affect the downstream treatment of food waste into, for example, compost or fertilizer. I mean, the technology for food waste treatment is there, it's mature, but most of the technology cannot take so much foreign materials. So the sorting of these foreign materials is very important to the success. On the other hand, after you have the fertilizer or compost, is there a local market? We all know that in Singapore, we can use some fertilizer imported from other countries and it's not expensive. But if it's from food waste, will everyone have an open mind to use it? Can they tolerate the foreign materials inside? Because you cannot separate 100%. So this is another issue, the market demand and the mindset. About plastic waste, actually is even more difficult to recycle because of the contamination. Most of the time, plastic waste is entangled with food, with some other metal, paper, everything you can think of. And to separate these foreign materials, the contaminants are almost impossible if you have tried. So we know there are some research working on plastic recycling, upcycling to convert plastic into like carbon nanotube, or convert into fuel, oil, or use it in concrete. But the main issue is we really cannot get single stream clean plastic waste most of the time. This kind of single stream clean plastic only can come from industrial source, which is maybe a small part of the total plastic waste. So when we try to clean or separate the contaminant from the plastic waste, we are going to generate plenty of secondary pollution like wastewater. And how are you going to deal with that? If the plastic recycling do not add much value to the waste, then maybe it's just easier to burn it. So that's the fact for low plastic recycling rate. And for ash and sludge, that's another stream of industrial waste. Most of the time it contains different types of pollutants, need to be addressed before it can be used as construction material. So we will come to that later. For textile, glass, and other waste, also collection issue. It's very hard to ask people to clean it and just throw to the separated bin. And also we may not have the resource to go door to door to collect this kind of waste. So with the current technologies, it's very difficult to achieve zero waste or zero discharge. Sometimes it may not be economical to do that, or it may shift one problem to another and cause secondary pollution. So when we judge whether technology is sustainable or not, we need to look at the whole life cycle of it. On the other hand, Singapore needs a lot of construction material for buildings, construction. We all know that the construction material is getting more and more expensive, especially for reclamation sand. We have a huge market demand for reclamation. 20% of Singapore's land is from reclamation and it's still increasing. So we need to import a lot of sand, but some of the country has banned the import of sand to Singapore. So we need to look for alternative sources for land reclamation. And with the sea level rise, we will need more material to raise Singapore's lands to avoid the loss. So looking at these two issues, treating and converting waste into construction material will not just alleviate the stress from high disposal costs of the waste and the limited landfill space, but it can also provide alternative material supply for Singapore's construction industry. To treat and convert the waste, we can do this 4 tiers of waste utilization. Number 1 is marine. By marine, we mean anything that will be in contact with the ocean. It's like reclamation fuel or caisson fuel or shoreline protection concrete. For second tier, the unbonded utilization, it include like road construction, fuel material for earthwork, because they are not encapsulated by any materials or liners, so we call it unbonded. Bonded material means materials like concrete, waste used in concrete or the bitumen layer of the road surface. And the last one, landfill, is for landfill capping, because landfill is a unique scenario, so it can be a safer disposal option. And then we consider which tier we are going to use the waste. We need to look at economical, engineering, and environmental aspects and find the best combination of the solutions. Because of the unique scenario of each category, the risk assessment of them will be different. For example, the bonded material, like concrete or road surface, they will have less contact with rainwater or groundwater. So we can have a lower environmental, more lenient environmental standard. But the manufacture of this kind of product will cost slightly higher than the unbonded or marine. So when we decide which one is safer, of course we will go for the bonded material. But if you look at the economical aspect, marine and unbonded may cost less to treat it. So we really need to look at the whole picture when we decide. And one of the major barrier for waste to resource is the pollutants, especially heavy metals in this kind of industrial waste. Heavy metals can migrate from air, through air, water, soil, into human body, and they can get into the food chain, accumulate in the stock, fish. Eventually, they will be consumed by human. And this will cause detrimental effects to human, acute and chronic, even cancer and death. So to solve these problems, our company, ZA, actually was formed with the target to solve the waste and wastewater and convert waste into safe and green construction materials. We develop and implement cutting-edge technology to solve the waste problem for all sectors. Our focus area including solid waste treatment and urban mining, wastewater treatment, environmental consulting. We also provide specialty chemicals to treat different type of pollutants, including heavy metals. Our expertise including incineration, bottom ash and fly ash treatment, wastewater treatment, mainly industrial wastewater, and sludge sediment treatment with organic pollutants and heavy metals, soil and site remediation, and urban mining, extract resources from the waste and wastewater. And environmental consulting is for government and big organizations to do some feasibility study, environmental standard setting. So one of our core technologies is called Tech. It's a series of specialty chemicals that can treat heavy metals and other pollutants. They can capture and transform heavy metals into their least soluble, mobile, and toxic forms by forming stable compounds. And they can help the clients to meet the most stringent environmental standards with lowest cost and simplest process. Another application of our technology is incineration bottom ash to new sand. We have conducted this project 2 years ago, and it was a success. In the middle, you can see the original incineration bottom ash, which has all kinds of foreign materials like unburned or metals, or organic pollutants, soluble salts, and most of them need to be removed for the downstream applications, including road construction, concrete, land reclamation. So the background picture, you can see that these are the metals and unburned materials and aluminum particles separated from the ash using our WCI process. And after the separation, we treat the heavy metals with our specialty chemicals so that the leaching can pass the stringent standard ascribed by NEA, and the final product will be like this at the corners here. It looks like a mixture of sand and gravels, but it's not as good, not as strong as sand and gravels. So when we apply bottom ash for road or concrete, we need to look at the engineering spec. To make the engineering spec, we need to do some tailoring of the treatment process. In the end, it will be able to replace most of the sand and gravels in all this construction. Another issue we talked about just now going to the landfill is the incineration fly ash, which is also generated from incineration of our municipal solid waste. The fly ash is like a fine powder, like flour, and is easily flying. So it's a hazard to people when it's being used. That is why incineration fly ash is not advised to use in most of the countries, and it should be treated properly and landfilled. So when we conduct the IFA treatment, we will use our specialty chemical to stabilize the heavy metals, which is the major concern of the fly ash, and it can pass the leaching standard of the landfill. And that means it can be safely landfilled. The volume will be reduced slightly, and the waste will increase by a little bit. However, there's a trend in the world now due to the decreasing landfill space to use the IFA for construction, mainly after thermal treatment. For example, it can be washed and used for cement manufacturing. That's being practiced in countries like China and some Asian countries like Japan. So the next topic is about non-incinerable waste. We have so many pictures here. You can see there are all kinds of non-incinerable waste from ash, byproduct, sludge, bottom ash flash, steel slag in Singapore. And most of them are not recycled. They are going to the landfill. Every day we have a few hundred tons. The main concern is the pollutants inside. Sometimes they can be categorized as hazardous waste. Sometimes they can be treated to be non-hazardous. So if we are going to recover the non-incinerable waste for construction use, the first thing to do is to identify the pollutants inside. And because of so many streams, it's not an easy job. We have been conducting this kind of characterization and leaching tests since 10 years ago. We found that some of the non-incinerable waste are actually good for construction, but they need some level of treatment. On the other hand, how good is good for treatment? So we will need a standard as a benchmark to compare. After treatment, we will conduct some kind of leaching test or total element content test. And if we meet the standard, it's a goal. But unfortunately, we still don't have a universal waste to resource standard in Singapore. I think NEA is working very hard to come up with the first standard soon. But right now, we have to go case by case. So we can refer to overseas standard like from European Union to judge whether the waste is safe to be used. Of course, it will be perfect if we can develop our own standard because each standard was developed based on the specific scenario and the consideration of the country. So after treatment, this non-incinerable waste, including the bottom ash we talked about just now, can be used for concrete or road construction, bricks, concrete bricks, not thermal bricks, and sub-base and base for road construction, land reclamation. These are some pictures of the real application site. To sum up, to achieve a near zero landfill is not impossible. It's a must for Singapore to achieve our goal to extend the lifespan of Samcorp landfill. And there are 3 steps we need to do to achieve a near zero landfill. First, we need to categorize all kinds of solid waste to identify what are the waste can be used safely with some level of treatment. What are the waste are hazardous, too hazardous, that need to be treated and landfilled. So we cannot avoid landfilling. We always have some toxic residues. Even we treat the hazardous waste, we will generate some sludge or wastewater. And after wastewater treatment, we have the wastewater sludge to be landfill. So in the end, the pollutants will be concentrated in the landfill and become protected by the capping and liner. And then lastly, we will need to have this environmental standard as a guideline for all the waste treatment companies and off-takers to have a instruction on how to carry out this waste to resource practices. With that, I end my presentation. Thank you for your attention.
Thank you, Dr. Sun. Next, we have Dr. Daniel Wong from Sembcorp Industries, who will discuss the challenges in developing waste to worth solutions. Daniel?
Hello. Hello, good afternoon, everyone. Thank you to the organizers of Tech Innovation for having me here on this event. Okay, so today's topic is really it's about challenges in developing ways to work solutions. Let me begin by sharing this. Right. To have a better appreciation of the challenges in developing a waste to wealth solution, it is important to first distinguish between what is waste management and what is waste to resource management. Both approaches are quite different in terms of the end objectives. In waste management, the focus and objectives is on sanitary management of waste. This means basic sanitary management of waste at the lowest possible cost. In many developing economies where the infrastructure for managing waste is still lacking, the tendency is for governments to focus on waste management. Now, in waste to resource management, the focus and objectives is quite different. It is on really the regulated use and conversion of waste into a renewable resource. This objective is practical only when there is already a well-established infrastructure and services in place to ensure sanitary and basic management of waste. Now, we tend to see this practiced in OECD markets where where the waste-related services in those markets are being transformed, are going through a transformation from basic waste management to waste to resource focus. It is important to identify whether a market is leading towards waste management or waste to resource management. By examining the policies and market mechanism, one can surmise whether that a certain market is leaning more towards waste management or waste to resource orientation. Many governments around the world tend to declare interest in both approaches, but really the details in the policies and market mechanism indicate a lean towards one or the other. To understand the challenges in developing waste to resource solution, we must also try to understand the macro drivers for such solutions. There could be many factors driving the waste to wealth trend or not, right? Some of these reasons could be related to climate change and impact of non-actions, or the important link, the understanding between the link of sustainable development and economic prosperity. Basically, you just cannot grow without caring the environment, taking care of the environment. Increased public awareness also. I mean, due to the access of information through the internet, people become more aware of the environmental costs. Change in mindset of behavior and behavior of the society, especially with the younger generation, where there's a heightened individual stewardship towards the environment. And some governments may pursue a green agenda because of political correctness, not so much, they believe in it, but rather political correctness. And of course, companies pursue green agenda because of opportunities and business and the opportunity to make more money. Now, there could be many reasons, and some are debatable. Some reasonings could be subjective and relative, and that's all okay. But the more important question to ask is, will these drivers diminish or change over time? Will the waste to wealth trend fade out over time? Now, this is an important question because if the drivers and trends are temporal, then the urgency and need for waste to wealth solutions are going to taper off, making it more challenging to develop these solutions. Okay, the next slide shows some examples of waste to wealth solutions. The pathways mentioned here are not meant to be exhaustive, but rather for illustrative purposes. I also do not intend to go into the details of these technologies. Some are quite technical, and I'm definitely not well qualified to comment on every technology in a public forum. Now, until recently, most people are aware of the use of waste to make electricity via combustion, or what we call the EFW plant, energy from waste plants. They are very common in many countries. It provides a very practical approach of waste management by combusting the waste, and along the way, electricity is generated. Some may view the electricity generated as green, but in reality, we look at the carbon emission given out at the stack of most EFW plant. It is sometimes no better than a conventional fossil fuel power plant in reality. Some OECD countries are already beginning to recognize this and are introducing more progressive policies to promote practices that are oriented towards higher waste to resource practices. Today, we also hear of the interest to convert plastic waste into renewable plastics to reduce the need to extract more virgin fossil-based resources. There are also parties that use waste natural oils to make renewable diesel and even sustainable aviation fuels. Some parties are even attempting to use municipal solid waste as a feedstock to make advanced fuels and renewable chemicals. In the food sector, it's also a very busy sector. The approach to convert waste into animal feed, fertilizers, biogas has been around for actually quite a few decades already. But what has changed, in my view, is the technique to do so. Some employ insects as low-cost approach to convert food waste into animal feed and high-value products like keratin. Or some even use bacteria to convert used cooking oil into, chemicals like PHA, polyhydroxyalkanate, a precursor for making biological degradable plastics. Other technologies are based on an understanding or better understanding and control of the bacterial reaction to improve yield and reliability of such processes. And these are really recent advances in technologies. Some solutions also involve the use of incinerated ash as a feedstock to make construction materials, like what we saw in the presentation before. And in some of these techniques, it even involves the sequestration of CO2, carbon dioxide, to make a construction material. And some even convert instead of making construction material, turn ash into aerogel, an advanced insulation material typically used in high-end industries like the aerospace industry. Now, all these techniques and solutions are interesting and promising, but they must be implemented under the right social, economic, and commercial setting for it to take off, become an effective solution for the markets. Okay. Now, on challenges, I try to group the challenges of developing a waste to worth solution into 8 considerations. They are not exhaustive. Now, the first 5 are relatively straightforward and easy to understand. The first is the challenge to ensure that the solution is technically viable. Now, this is a given, all right? For any solution to work, it must work, all right? One must make sure that the yield rates are acceptable per unit cost, and they are better than the baseline business as usual situation. We must make sure that the process is reliable and dependable, and can really operate in a real life environment and not just in the lab, right? Sometimes one of the speaker mentioned, if the process requires, let's say for plastic recycling, if the process requires very clean single stream plastics, then that is not a solution, because in the real world, it's very difficult or nearly impossible and very costly to find single stream clean plastics for recycling. So second, scalability. Scalability is another challenge that developers face. Is it difficult to scale up? Will the access to feedstock constrain the attempt to scale up the solution to a larger plant? If it can't be scaled up, then it is very unlikely that it can be a mainstream solution. Third challenge involves logistic and infrastructure support. Does the solution require new supporting infrastructure to be built in order to implement the solution? I quote an example, recently, waste to hydrogen. There were parties proposing making hydrogen from waste. Now, that's fine. But one needs to ask if if supporting infrastructure is needed in order to facilitate the use of hydrogen, right? And is such infrastructure available today? It may turn out that building such supporting infrastructure may be more challenging than developing the solution of converting waste to, hydrogen itself. So this is one example. Another example that I come across is the need to pre-sort or segregate the waste for waste conversion or a waste conversion solution. The challenge is not so much the conversion, but rather the difficulty in getting pre-sorted segregated waste when such infrastructure, for example, a material recovery facility, is not widely practiced in a certain market. Fourth challenge would involve the understanding of having a clear, or rather involve, the fourth challenge is about, having a clear understanding of the value proposition of the solution along the entire value chain. This means, a clear identification of the value add this solution can create with respect to the entire value and service chain. Is this value add significant, or is it only marginal? Are there alternatives to this solution if available to stakeholders of the value chain, right? Does it stick? This solution, does it stick? The fifth challenge is about picking the right business model and market, to introduce a solution. Now, this is pretty common sense. It's important to pick the right business model for a technical solution. It's not so much, one has to decide whether the business model is about technology sales or is it selling a service using a technology. Both are quite different. Usual things like development costs, cash flows, and managing finance, I think these are all given also. And choosing which geographical markets and industry sector, and understanding whether that geographical market or industry sector is in a waste management mode or waste to resource mode. Questions like, will these market drivers fade out? I think these are things that one need to ask. And incentives, normally in some emerging sectors, you will find incentives. Government would introduce incentives, but a business model shouldn't be built on incentives because we know that incentives do get taken away one time or another. All right, the three remaining considerations are not so easy to figure out. It requires some educated guesswork, and in my experience, these are more difficult to deal with than the first five that I just mentioned. The sixth challenge is about determining the economic viability of the solution. Is it relatively easy? It is relatively easy to work out the economic viability today. But what about the economic viability 10 years later? Who can predict, right? Many waste-to-world facilities tend to be very capital intensive and are designed to provide a long-term service to the industry. So sometimes, very often, predicting the economic viability of the solution in the future becomes a very difficult affair. It's like an art and also science combined together. Things like the price of consumables and price of product, one has to make a guess, an educated guess of what it will be in the future to come. The next challenge is the challenge in facing the challenges, in facing the changes in regulation that will be expected. Now, the old adage that the only thing constant is change. Regulations will change, okay? So a game plan must be developed in order to navigate through these challenges. The last challenge is about trying to understand the business environment and picking the right time to introduce the solution into the market. Sometimes it boils down to chance, but it would help if one can understand whether the market is ready for the solution. Is the solution too early or too advanced for the market? Will the market change? A view needs to be formulated to estimate the change in the market in terms of the direction of change, the speed of change, and also the impact of the change of the market. we also have to take into consideration that the competition is not stagnant. It will move, all right? And what are the new technologies that are in development today, and how will the competition fare, or how will your solution fare when these competition are scaled up and introduced into the markets? So these are these eight considerations are definitely not exhaustive. I'm sure many in the audience will be able to identify more, and some would even have personal experience in confronting these challenges. But I hope my presentation will at least single out some of the more obvious challenges. And with that, I end my presentation and hand the time back to the MC. Thank you.
Thank you very much, Daniel. Now, before we proceed to the panel discussion segment, we'd like to encourage you to submit your questions in the Q&A feature on your screen. Kunal Shah, Managing Director, Sales Asia at Anaergia Singapore, will be the moderator for this panel discussion. We will invite our 3 keynote speakers back on screen as well. Over to you, Kunal.
Thanks, Alvin. Good evening, ladies and gentlemen. I'm sure you enjoyed the presentation by our 3 stalwart speakers, Dr. Daniel, Dr. Sun, and Morgan. What a great timing to have a discussion on waste. Frankly speaking, we were thinking even with COVID-19, the quantity of waste across the world kind of has increased thanks to the take-home and deliveries and a lot of packaging stuff being used. A lot of medical waste has increased, and so on and so forth. And I think this is a topic which touches not only you, me, or the speakers here, but I think this topic touches every individual soul on planet Earth. Every industry, city, every country has to deal with the topic of waste management. With that in mind, I think what we saw today, just a summary, was that we heard today how a family business turned into doing business differently and sustainably, thanks to Roger&Sons. We also heard from Dr. Sun that how technologies can enable and assist in resource recovery and waste to work, and the opportunities which lie ahead for us here in Singapore and the region. And again, very nice presentation by Dr. Daniel on the challenges. Opportunities are there, but there also lies challenges because this sector is quite complex compared to the other sectors. So with that in mind, I wanted to quickly run a few questions with our speakers here, and I'll start with the same chronology. This is to you, Morgan.
Yep.
Your work at Roger&Sons is a true example of how businesses can transform and support the cause of sustainability and growth. Can you share how your family, led by you, went about reinventing the way your family business was being run? Maybe some examples of how it all started will be great for your audience to listen.
Yeah, okay, sure. I think, the carpentry industry is quite similar to the hawker industry, right? So the people in the industry are slightly older. There are not many young bloods coming in. So my dad, like I said, my dad started the business about 30 odd years ago. He passed on about 7 years ago, and that's where me and my brothers took over. A lot of things that we've done is by circumstances. So, when we first took over the business, me and my brothers we were young blood, right? So we had all these big dreams and big ideas. And one of the first things we realized is how unsustainable this industry is. In theory, how I make a living is by killing trees, right? I kill trees for a living, and basically that's what I do. And as I see the processes and how the industry is like, it's actually easier to dispose of things and instead of making new ones. A clear example is, whenever I get new clients coming in, for example, they get their new condos, the first thing they will ask me to do is to tear down the new wardrobe because it's too small, right? Because the houses are really small right now. And so after I observed and realized, we really wanted to be sustainable. But being sustainable is quite difficult in Singapore. So I think what we've done over the last couple of years is making use of whatever resources and circumstances we have, put it to our advantage. So when we took over the business at the time, there were only 3 or 4 guys that were in the business. And then we decided, hey, let's not go and compete against the big boys with all these big machineries and everything. Let's focus on small items, being bespoke, trying to do things better. yeah, it's a great idea, but it's purely our circumstances, right? And from there, we tried to do a little bit more. We tried to explore, even with working in Mandai, we met really nice partners. When we talked to them, we told them that, hey, we are new. It's our first time working on projects like this. Do you want to go on this crazy adventure on us to explore together with us? So whatever we have done so far is taking small steps. We have the big picture that we want to do. Eventually, I want me and my brothers, our biggest goal is whenever we take a tree that's cut down, and by the time we finish the furniture and it reaches its lifespan, that it can be put back into the ground and then it can just just breaks down on its own, and so we don't have to do any processing. So that's the long-term goal. We are so far from there, and for me right now, it's just taking step by step.
Understand. Thanks, Roger.
Yeah.
I mean, if I were to summarize this for our audience, I think what I heard is that first, the charity begins at home. So you and your brother thought that sustainability is the way forward. You walk the talk. And I think thinking out of the box, conventional things, many people are doing it, but you decided to do something out of the way. And I think that transformation or that thought of a transformation is very important. Thanks for sharing that, Roger. I move on to Dr. Sun. As a person who comes with an R&D background with so many patents on your name, how do you think technology can play a fundamental role in advancing the cause of sustainability?
Thank you for the question. If you open the history of science and technology, 10,000 years ago, we faced food crisis, and the agricultural revolution solved the problem eventually. And in the 20th centuries, we have energy crisis and nuclear power and renewable energy spring up. So currently we are facing this COVID-19 crisis. As we all know, clearly the only solution is still technology. Every time it was science and technology that keep mankind sustaining and evolving. Back to today's topic about raw material shortage and urban mining, we know the resources of many minerals and metals are limited, and recovering them from waste requires effective collection, separation, and purification. The technical and economic feasibility of this urban mining largely depends on the level of recovery technologies. For example, we can integrate sensors, robotics, or AI for easy collection and separation. We can design more efficient waste treatment systems and processes, and we can develop cheaper and safer specialty chemicals for purification process. It's always technology that will lead to the fundamental and drastic change in achieving sustainability. That is one of the reasons our company choose to devote ourselves to environmental R&D.
Yeah. That's great, Dr. Sun. Congratulations on doing that. And I like the analogy: food crisis, energy crisis, COVID crisis, and now I would say there is a waste crisis also. And it affects every country. And I think you're right. We are sitting on a conference virtually. It looks like you're in the second room, and I can see you. It's all because of technology. So thanks for sharing that thought. I'll move on to Dr. Daniel. You have experience of operating quite large waste to energy facilities in the region, in Singapore. And how, in your view, you just now mentioned that waste to energy is no more just putting waste into a burner and burn it and dispose it. How do you think that has transformed over years to be a more sustainable and treating waste more efficiently?
Okay. Well, as far as I know, I think waste and EFW solution was first introduced in the 1960s, before I was even born, before all of us were even born. Starting with Europe and then gradually moving to China in the year, in around 2000, the early 2000s. So the EFW market has indeed evolved to be more sustainable in a number of ways. First, we see improvements in emission control on particulate matters, dioxins, NOx, SOx. These are the scrubbers, things like SNCR, the SCR combustion and even control of combustion temperatures to get a leaner flue gas. We also see improvement in monitoring technologies in monitoring these EFW facilities to ensure that they comply. So this is also a very important development phase of the EFW industry. Better materials in terms of high temperature resistant alloy, ceramics and things like that make a EFW facility more reliable. But EFW does have a very, have some its problems that are not easy to solve. Things like carbon emissions at stack. It is still a very pollutive in terms of the flue gas. Of course, better than landfills, right? But emission at stack is still another problem. And like what Dr. Sun said, the bottom ash, bottom ash that is created is also another big problem. It's not easy to manage this bottom ash. It's actually quite costly to do so, to convert the ash into a safe material for construction use, right? But recently there has been some developments, things like carbon capture at stack to reduce the CO2 emission into the atmosphere. And this CO2 is captured and scrubbed and cleaned for secondary use, and in some cases even sequestered, in the form of creating a new construction material.
I see.
Yeah. But recently, some new technologies like gasification do make a big difference in terms of they are a lot more cleaner, and they also open up new avenues to not just make electricity, but also convert the waste into higher advanced energy sources like a fuel or chemical, a renewable chemical. So these are things that have evolved to make EFW more sustainable.
Thanks for sharing that, Dr. Dan. It looks like there is like a sea change in how the waste has been managed, and clearly there was a question about Sembcorp managing. I think you have answered that question already from one of the audience guests, that how these are some of the new technologies which are coming out, and how Sembcorp would also be kind of using them. Just before we move, Elvin, how much time do you give us further to discuss this panel discussion? Like 10 minutes, so that I can manage the questions accordingly. We have quite a few questions from our audience here. How many minutes can we go further? 5, 10 minutes? Maybe 2, 3 questions?
4 minutes? We have 4 minutes.
4 minutes. Okay, let me make it quick then.
Yes.
So, then I'll take the questions from the audience. Morgan, this is to you. There are a few questions that, when you, and please try to see if you can answer in a short and a crisp manner.
Yes, of course.
So Morgan, when you make a furniture out of a log, what do you do with the trimmings which happen or comes along? That was one question. So you would like to answer.
I mean, to be honest, right now, most of the waste go to the incinerators. So we are exploring what we can do with it, but I think for us right now, we don't have the capacity. We're just one company. Yeah, so at this moment in time, it goes straight to the incinerators.
And the other question again, Morgan, because I'm just going through the list for you.
For sure.
Do you see a difference between the trees in Singapore, like the densification of wood in Singapore versus overseas? And how is that better for making a furniture, for example?
Oh, this is a good question. I think the problem with trees is that trees are live, right? So the moment you cut the trees are wet, you need to dry it. But the great thing about Singapore trees is because they're very accustomed to the Singapore weather. So, I mean, most of the issue is working the trees is through education. I don't have the knowledge, I can't go to NPark, so I can't go to any school, nobody talks about local wood in Singapore. And that's why research and development is very important on this. And then the next step is to show and educate the public as well as different people, on how these wood are. So in theory, the wood, there are different tiers of wood, but local wood is really just good enough to be able to do and meet most needs out there in the market.
Thanks, Morgan. And there was another question related to cost. So, like you're making a sustainable furniture. Of course, it comes at a price. And do you see a good market response? I mean, like youngsters need to buy more sustainable furniture?
Yes, correct. So I mean, ever since 3 years ago, there definitely been an increase in interest for sure.
Okay, fantastic. And I move on to Dr. Sun to you.
Yes, for sure. Yes.
Okay. And thanks, Roger. So Dr. Sun, I mean, a question to you somebody was asking is that, have you explored the use of seaweeds as a natural filter for handling heavy metals in wastewater?
I heard about that, but we haven't done this kind of bio-related research for heavy metal treatment because we don't have the that kind of dedicated lab. We need some biologists to study this kind of research, but it's a good idea. it can reduce the treatment cost significantly if we can tap on the CV.
Great. So the person who has asked the question can approach Dr. Sun and maybe something good comes out of this session. Dr. Sun, there's another interesting question that, usually when there are various contaminants and then you add more chemicals and additives. So there is a question that, how about the leaching behavior on short term? It changed, but, what are the risks associated with this to be leached into the flora and fauna? And what is your view?
I'm sorry, the leaching of fluoride.
So it says that with the variations in contaminants, would all the chemical additives needed be a risk on the long term? When you add chemicals, would that be a risk?
Oh, I see. There's some kind of treatment specialty chemicals may have secondary pollution. So when we add the treatment chemicals into the waste or wastewater, we need to control the dosage. And of course, if we can use the non-toxic chemicals, it will be better.
Fantastic. And Dr. San, there is also an audience member who says that he wants to meet you and talk a lot about a lot of things. So,
okay.
I leave it to the organizers to connect you. Daniel, I think there was an interesting question, but I think you've already answered that how Sembcorp is applying some of the latest technologies. Do you want to cover that like in a sentence? And how are you at Sembcorp embracing new technologies? Just a few examples.
Well, yeah, we are constantly on the lookout for new technologies. And it's not just also about the technology, the readiness of the technologies, but it's very, very much so the economics of doing so. And as I mentioned in the presentation, understanding the entire value chain of the solution is very important. So I cannot really name, I think there are too many to name in terms of technology. I don't want to do that, but I think the thing to highlight is that it has to be looked upon as not just the technology, but also the economics of it, and the sense of doing it, the sense of doing it. Yeah.
Understand. Thanks. I mean, now I think, Alvin, we have surpassed our 4 minutes, so I would like to summarize it. We kind of covered the questions. I think it's an interesting topic. You heard from all the three speakers that there is so much happening in the waste space. The time couldn't be better than the time we are in right now. I think there could be a collaborative approach, cooperative approach. We are all locked into a nice country, and then I think there could be more coming out. Surely, waste to worth is the way forward. Thank you all for listening in, and thanks, speakers, for sharing your thoughts in this session.
Thank you.
Thank you.
Thanks, everyone.
Thank you.
Thank you very much, gentlemen. Thank you very much, Kunal, for wrapping it up. Despite the time constraints, it was a very engaging session. We have now come to the end of day one of Tech Innovation 2021. I hope everyone has enjoyed today's sessions. Here are some administrative notes. Please click on the info button on your screen to submit a rating out of 5 stars before exiting this session. We look forward to receiving your feedback. All webinars from today will be available on demand via this virtual portal until the 1st of October 2021. So you can catch up on the sessions that you have missed. The webinar live stream will be open at 8:45 a.m. Singapore time tomorrow. We will have exciting sessions on sustainable food and nutrition lined up for you on day 2 of Tech Innovation. So don't miss out on the challenge briefings from design think tanks, participating enterprises, as well as the launch of an open innovation platform, Sustainable Startup Factory, for startups in the food and tech area at IP Hatch 2021. Day 3 of Tech Innovation 2021 will also reimagine health and wellness innovations and solutions, including non-invasive healthcare diagnostics and evidence-based traditional herbal medicine. Check out our key partners on-demand technology showcases by selecting 22nd September under the agenda drop-down list. You can also chat, secure a virtual one-to-one meeting, or request for a callback with exhibitors by clicking the Connect button in their profiles. If you are interested to speak to IPI tech experts, simply search for their names via the Attendees button. Thank you once again for participating in Day 1 of Tech Innovation 2021, and we look forward to welcoming you back tomorrow. Thank you.